Question 9. A long, thin, straight wire carrying an electric current I causes a magnetic field of flux density B at a perpendicular distance r from the wire. The magnitude of this flux density is given by the following relation: B equals alpha I over r, where alpha is a constant. The magnetic field points circumferentially around the wire. A second identical wire is placed parallel to the first one at a distance d. Find the current I2 that has to flow in the second wire if the flux density at a line halfway between the parallel wires is to double compared to the flux density from only one wire at current I. So lots of information to digest here. Let's just draw a little diagram to see what we've got and what the question's actually asking us. So we've got two current carrying wires, both identical. One of current I, the other of current I2, which is currently in unknown direction. We know that we've got a B field that is around the circumference of each wire, because that's how B fields work. And what we want to find is the value for I, which is the current in this second wire, for which the B field halfway between the two wires doubles. Okay, so let me draw this diagram slightly differently. If we consider the first wire going into the page, then there'll be a B field going around it like this. And using the right hand rule, if the current's going into the page, you should see your fingers curling around to the clockwise direction. Now if we consider the other wire, again we don't know which direction it's going yet, but what we want is basically an identical B field that's going in the anti-clockwise direction. And what that will do is double the B field here, because the B fields are just vectors and they sum. Okay, so hopefully that makes sense. So we've got a B field from wire 1 going clockwise, and what we want to see in order to double the B field in the middle of the two wires, we need a B field going in the anti-clockwise direction from the other one, from the other wire, from wire number 2. Now, again using the right hand rule, you should see that your thumb will be pointing out of the page. So that means that I2 will equal minus I1. And then for the magnitude to double, we just need these two B fields to be the same, which means the magnitude of the current in the second wire will be the same as well. So this is what we're left with, I2 equals minus I1. So the answer is D.